Obviously, you guys all know PEMDAS. You all are familiar with that, so I'm just going to throw that at the top. And actually, over the years, that's probably the traditional way you've seen PEMDAS written. I've sort of wondered why it's not written like this. Anybody know why? What I might be onto by thinking it should be written a little bit differently? Perfect. This kind of, to me, makes it look like multiplication has to come first, followed by division, which is absolutely not the case. These two are interchangeable. It's whatever comes first, left to right. So if I have like 12 divided by 3 times 2, I definitely don't do the multiplication first because M comes first in PEMDAS. I do left to right. Division comes first. That's 4 times 2 is 8. Yes. Yep, he's here. Yes, sir. No problem. Dave, will you just take the class and go see Mr. Hylock, please? So anyway, that's kind of why I think, and the same thing goes for addition and subtraction. Addition does not come first unless it is found in the expression first as you move from left to right. So anyway, other than that, I think we're all good. So on the first example here, parentheses means, is there anything to simplify within the parentheses? And we obviously have parentheses here, but there's nothing to simplify inside of those. So I can't combine those terms because one's an x squared and one's an x. So that's done. Exponents, there's nothing that I can square here. There is an exponent in the problem, x squared, but I can't actually square x without knowing what x is. So there's really not even much to be done there. Really here, just multiplication, distributing is obviously going to come first, so go ahead and do that. Six gets distributed, the 10 gets distributed, and we combine like terms. So 40 and 12 makes 52x squareds. 24x's, 30x's makes 54x's. Two gets a little bit trickier. Probably on the forefront it actually looks simpler, but I would say it's probably a little trickier because anytime I see parentheses within brackets, within parentheses, it's just kind of messing with the eye a little bit. My advice, always start on your innermost set of parentheses. In here, is there anything to simplify? No. Look out in front of that set of parentheses and see if there's anything to be distributed, and that answer is yes. I'm going to keep everything else the same here and distribute the negative. So 8x plus 5, and then minus an x, and minus a negative 3 is a plus 3. So within that set of brackets now, we do have some simplifying. We can add those the 5 and the 3 together. So 8x plus, and my brackets can become 8 minus x. Now, as far as those brackets are concerned, is there anything to be distributed to those? Not really. Technically, you might be able to say, yeah, you distribute a plus sign, but we all know that that doesn't change a thing, so you really don't need that. 8x plus 8 minus x, and we get 7x plus 8. Thank you. Okay, 3 is going to be just, I don't know, do you guys call it foiling? Do you call it double distribute? Foiling, okay. Either way, well, I'm sure you are familiar with one of those terms. They mean the same thing. So, distribute your x first. X times 3x is what? 3x squared. X times negative 5y. Very good, minus 5xy. We move on and now just distribute the 4y. So 4y times 3x is plus 12xy. And 4y times negative 5y is negative 20y squared. And we just have those middle two terms which can combine. So negative 5 plus 12 puts us at 7 of those. Any questions so far? What's your strategy on 4? Expand it, right? Like, actually, so you just write another one next to it, Christian? Or if you want to start fresh, you can just rewrite it there. And then it's the same problem as the last time. So we get 25x squared plus 15xy plus another 15xy plus a 9y squared. So we get 25x squared plus 30 of these. Now, it's not necessary, but in amongst a bigger problem, and when you're sick of writing, you may want to understand this. Is there anyone who can explain how you would work the shortcut to get you right from the original, right to the answer without having to do all that in between? Like, do you see where the 25x squared comes from? Right from the beginning? Yes. And I think it's pretty clear where the 9y squared comes from right from the beginning. But where's that, what could be a shortcut to get that middle term when you're squaring a binomial? No, that's a good guess. It's a different strategy for a different kind of a set of instructions, Connor. Double that. Yes, exactly. If you multiply these two terms, you're going to get 15xy. And you did get that when you did, you know, this here. It's always just going to happen twice, though. Your outer multiplication and your inner multiplication is always just going to be a repeat. So whatever that product is, if you just multiply the two of them, in this case positive 15xy, if you just double that, knowing that it's going to happen twice, that will always get you your middle term, if you're looking to save time. It can get a little more complicated if you've got something like, let's just add this for example, 3y squared plus 2x squared. That may be a little bit nastier, but let's try it. What will the first term be? 9y to the 4th. And think for a minute, raise your hand when you think you know what the middle term is going to be. What's your name sandwich there in between Brock and Christian? Carolina. What do you think?
So 3 times 2 would be -6, and then round that would be 6.
Double it, not square it.
Oh,
12 x squared y squared. Yes? Okay? Because you multiply these two, exactly what you said, you'll get 6x squared y squared. Double that, 12x squared y squared. Okay? So that is our middle term. I'm showing you this because it can get a little tricky and maybe not worth it if you're, but this one would be tricky anyway, even if you did expand it, to be honest. Anytime you've got different variables with exponents on each of them, it does get a little bit uglier. And then your last term would be 4x to the 4th. So plus 4x to the 4th. So for what that's worth, I always try to encourage my Algebra 2 kids to pick up on that. But at the end of the day, I would prefer accuracy, so if expanding it is the way to go for you, please do. Okay? But if you ever were doing 100 of those in a row, you might want that shortcut. It would just be a lot less writing. All right, number 5. Now, you can't exactly call this double distribute, or can you? I never use the term double distribute, so I know what they mean by it in the 2 by 2 sense. Would you use that same term for this? Or no, because it's 2 by 3. But in reality, what's that? You definitely can't call it FOIL. I mean, you can, and I think we would all know what you mean, but technically there's no first, outer, inner, last. That doesn't really work. But it is, you really just distribute. So, and even if when it's about to get uglier, which it will, trinomial by trinomial, you just start with your first polynomial. Distribute your 2x through, this time to all three terms, then move on to your 3 and distribute that to all three terms. It's just very methodical, just keeping it organized, working from left to right. So your 2x times x squared gives you 2x cubed. 2x times 4x gives us 8x squared. 2x times 5 is 10x. Then you move on to your 3, so just carry it on, plus 3x squared, plus a 12x, plus a 15. So in this case, I guess you can call it double distribute, because you distributed twice, the 2x and then the 3. This next one, though, I think you'd have to call triple distribute, because you're distributing a trinomial. You're going to distribute the 7x, then the 5, then the 4y. So go ahead for me, finish 5 just by combining like terms, and try 6 on your own using that concept of triple distributing. Faith, what'd you get?
49x squared plus 70x is 25 minus 16y squared.
Very good. Did anyone, so I actually, because I knew I wasn't going to have enough space working all the way left to right, I would have run out of space. When I distributed my 7x, I kept that in the top row. When I distributed the 5, I kept that in the second row, and I kind of lined this one up under its like term. The other two didn't have like terms. And then when I distributed my 4y, again, I put that in the third row, lining up the like terms. I just knew I was going to run out of space left to right. So I just did it that way. Whatever, we get the same answer. Did anybody see? Are you done? Are you out? It was great having you for 20 minutes. So, did anyone see anything here of interest? No. I'll tell Mr. and Mrs. Hill and myself that we did not do a very good job last year. Shoot. No. No. Any special pattern anyone sees now looking back at like the original problem? Reciprocal, I think you're on the right track. A reciprocal, though, talks about fractions being flipped. I know what word you're looking for. It starts with a C, my kids. It was on a flashcard. Yes! Christian, winner. So it's a very, very much so a hidden conjugate. So conjugates typically are like x plus 3 times x minus 3. And then when you FOIL them, they end up being the difference of perfect squares. Because your x squareds, you'll have a minus 3x, a plus 3x, which is a wash, and then a minus 9. This is conjugates a little bit differently. It's 7x plus 5 plus 4y, and 7x plus 5 minus 4y. So when you're kind of foiling that, in a sense, 7x plus 5 times 7x plus 5 actually creates that portion that you guys came up with. Your outer, when you do the 7x plus 5 times a negative 4y and a 7x plus 5 times a positive 4y on the inner, cancels, as conjugates do. And then your last two terms give you that negative 16y squared. So you kind of have here the difference, there's your difference, of a perfect square trinomial and a perfect square monomial. You do have the difference of perfect squares, like you do down here, because it came from a conjugate, and this did too come from a conjugate. So if you see that pattern, and it can be easier, go for it, but I just want to point that out. And then our very last one here, I know some of you already did that. If not, get started. Only look up if you need a little guidance on the way. I'm going to do it right alongside you here. Questions? Okay, I'll leave that up there for a second. So there's a little bit of a mistake on the way your homework's copied from this chapter. So, meaning I didn't mean for them to be double-sided. So this one is tonight's homework, and the back side is tomorrow's homework. So as you can see, this is from a textbook, so they're all very tightly wound. Definitely do your homework on a separate sheet of paper. I collect your homework every day, so even that won't work because tomorrow night you're 5s, and 7s. Okay? I don't know exactly why they're not in chronological order, but... Oh, because they're from 2 different sections of the book. So anything that ends in a 3, 5, or 7, that's your homework. So you can start that now, but